Great. Okay. So let me start. Um, Now, today we are just going soft. We are just beginning with a general topic. It's not going to be technical. It's going to be about the experience that I have had in my testing career and some suggestions around that. I mean, I have evolved throughout the time, and I have seen many of the testing world evolve around. So I'll just tell you my story and then my suggestions. We can talk about it. By the way, there is no like I talk and then question time. You can always interrupt and I'll always ask your question or your uh, input. So yeah, three stages of testing. I was trying to make this interesting by saying like three stages of water or three states of water. So this is going to be something similar. Well, and by the way, before going into that, I want to share you a nice coincidence because our name is Test Hive. Like it's a beehive. Our first slogan was a beehive for all quality freaks. So it was a nice coincidence that Manchester's coat of arms or symbol was the bee. So that was a nice question that okay that I wanted to mention and go on record with this. So yeah, this is about three stages of testing. Now, what I mean by that is this: uh, what do we understand when we say three stages of testing? What am I talking about? Am I making any sense here? What could it be? My point here will be this. As I started doing software testing, and I'll tell you why I started software testing, I am a software engineer. Now we call it a computer engineer back home. So what we do is basically computer science, right? So my university was a university that was very tough, and we had like at least one classes every semester that we had to submit 5 projects every 2 weeks. So you had to find I mean, you had to find your infrastructure for the project and then make a design report and then build the project, submit it, that kind of, I mean, and once you fail one of them and then have to take it the next year, you have to do 5 projects every year. And then that kept going very frustrating for me. I did the coding, I did development, but I hated it. I definitely hated it. Like my story was I was so obsessed with not doing coding when I graduated. When I had a job offer from a company called Keytalk back home, like they had this job advert saying that we are looking for software testers. I had heard about software testing back in school. I mean, there was a nice guy who came in and told us about software testing, but I didn't know how it was done, and I didn't know how cool it was. I mean, I always had a questioning mind, I always had an inquisitive mind, but then when I read the job description, software testing, you will have to like test the software and find bugs, and I kept reading about it, and then I liked it, and then I applied for the job. When I got the job, I was so excited to do that stuff without coding, and I still was called a computer engineer, by the way. I loved it so much, like it became just an obsession. Like I have this, I think, in my CV or somewhere. Like I love breaking things. As a child, I loved breaking things and trying to find weaknesses, and then I don't know if you had this, but like when I was watching a movie, if the protagonist, if the hero was getting like injured, I would be very obsessed with it. I mean, where's his injury? How does he keep doing that? That kind of stuff. It stuck with me, you know? So I loved finding those defects. And then when I got in, it was really cool, you know? I was working for the fifth biggest bank in Turkey. And I was actually finding some bugs, and I was finding bugs that would go into production, which would have cost like hundreds of thousands of pounds to the bank if it were not found, which was very cool. And then I started doing testing. Now, how was I testing? I was just doing it manually. There was nothing that, like, I had no idea what test automation was. I read about it, but I didn't see anybody doing it. In my mind, that was well, in that case, it was the situation that when people was talking about test automation, they would just record something and then replay it, modify it somewhere, and then we had HP QTP back then, and then we had HP Quality Center, which was both, of course, in the dreams of having a solid test automation system, but then nobody used it. Nobody knew how to record things in it. How even less people knew how to like modify scripts in it. It just sat there, and we had some runs, but we were doing things manually. Now doing things manually is not that bad actually. It's very cool to interact with people. It's very nice to find a thing and then go to somebody. Oh, I have found this. How can we fix it? That kind of. But it has some drawbacks. Now, when you do this, you are all doing this by hand, and you by hand, I actually mean by hand. I mean, you go into the application, click somewhere, enter some text, and then see the result, report it back. If you have test cases, and I always hated test cases, by the way. I was asking this question. We have this analysis document, and then we have the exact same replica in the test cases. Why do we have this test cases? That kind of stuff. And then you all do it by your hands. You do it every time that you have a new version. I didn't, I mean, I loved it, but that was some work. I mean, it was very laborious. And then you couldn't repeat the same thing that you did before. Like you can think that you are repeating same things, but as humans we are not that good at replaying things. So if we are doing the regression testing it with every version, we actually are missing a lot of things. So I still was trying to keep up. I mean, it was like this. We had like 6 or 7 screens at first, and then I was testing them. When there was a new version, the screen counts like go went up to 10, let's say 11. And I was doing the same test that I had in mind, and then going back with the new screens, and then trying to find some interactions there. I mean, it was some hard work. And then, of course, when you are doing all this hard work time and time and time again, it takes a lot of time, right? I'm not trying to describe what manual testing is here today. I'm just trying to give you the ways that I saw, like, which didn't make sense and which were cool here. So it took a lot of time. Like every with every version, like luckily in a waterfall project we didn't have that many frequent deployments, but like every month I had to go through all these things in my mind, and I was always wondering, did I miss thing? Did I miss this? Did I do this? Sometimes I would wake up, oh, I forgot to test this, and then again go remotely and then connect to the system and try to test again. And it's it's so prone to error. Like, I'll tell you a story. We were testing a banking application in Vakıfbank, the fifth biggest bank in Turkey, and I myself was in the test system always on the 12th branch, right? The branch code was 12. So I was doing my testing all the time there. So when we did our testing, for example, we deposit some money and then withdraw some money, we get some receipts, right? I was printing out the receipt and looking at the receipt. Everything is great. Everything is fine. And the branch code is 12. Good. The code goes to production and we have a report. Every receipt is being printed as it's coming from the 12th branch. So I missed it. I mean, because I was testing in the 12th branch that all the time, I didn't see that some developer had an embedded code somewhere saying that, okay, this is coming from 12th branch, and it went to production. I haven't noticed it. It was easy for us to just going and change the code in production, but I mean, it was some excitement. Like the branches open and, oh, this is 12th branch. Okay, cool. So that's very prone to human error. I mean, I'm not saying that humans are not needed. I'm saying that it is very stressful, and as a human mind, we have evolved in a way that we will forget about things unknowingly, and we will get used to things, and then we won't have the ability to think creatively as we did in the first time. So that's very prone to human error. And these capitals are the plus sides of every style, but that's very entertaining, right? I mean, I loved it. Everybody, there was nobody who knew the application better than me in that building. Everybody came to me, everybody asked me what's going on, everybody asked me what's wrong. I mean, think about me. I was 25 years old. I i have I mean, it had been a while I graduated, but that was my first like corporate job. And people are coming to me in my first year asking my about my opinion. I was going into meetings with the CTO, for God's sake. So that was something cool. It made me known everywhere. It made me a lot of friends. It made me a lot of enemies. But it was very entertaining. I loved my job. Sure, I mean, we were making some errors, but uh, once you get the grasp of things, it's very easy to fix this error very quickly. So here comes the second phase. Now, I was there, I was doing manual testing, but then this agile thing came up, right? uh, the year was what, 2010, and I know the Agile Manifesto was published in 2001, but we are talking about Turkey, so we are coming a little slower. So 2010, 11 even, we heard about this thing called Agile. So what is it? We were doing stand-ups, everybody was sticking stickers around, and then it is said to have a lot of deployments every iteration. That didn't happen very much. But then they told me that you had to have test automation. Okay, like I had used IBM's RFT back in the bank, and then we had HP's QTP. Easy enough. I mean, you go in, record something, and then replay it every time. Well, it was like that. And then I I met with a person. That person was a thought worker. I mean, he wasn't working for ThoughtWorks at that moment, but he showed me these cool things. I mean, he showed me this Ruby programming language, and I thought, yeah, yeah, I know something about programming. Maybe I can do something. And then he told me there's this cool thing called BDD and Cucumber, and then there's this cool framework called Capybara. Okay, what do they do? They just automate things. Good enough. So I started writing code, and like, believe me, it had been what, more than 5 years, 6 years even. I hadn't written a single line of code, and I was a computer engineer, so that was very entertaining for me as well. I mean, I was going in, doing what I had been taught in college, and then still testing things, which was great. Like I was writing automation scripts everywhere, like here and there. We can automate this, we can automate that. But then I started to get this sense I was automating things, but was I really testing? I was writing lots of scripts, but was I really thinking about the product and trying to give it a proper test? It had a big learning curve. Like, the most code that I had written in college was in C++, and the world has moved away. And then this Ruby was new for me, but I still loved it, like, because it didn't have that much constraints of a like object oriented C++ static language. But still, I mean, I had to learn new things. I had to learn things how it was done. Like, I still remember something, and I think I still have it on Stack Exchange. asked a question on Stack Exchange, and then nobody answered it. It was afterwards that I understood that the question was stupid. That's why that's why nobody answered it. I solved it myself, like reading through tens or like hundreds of pages, maybe, I don't know, and trying to find just one simple thing. Uh, but like after 2 months, I was getting grasp of it. Right? I was still in a company which was a kind of state-owned company, but luckily we had this ex-thought worker there who was working, and he was trying to implement this continuous delivery pipeline, which I have never heard about previously. And that's why I was able to like learn and implement it without the pressure of delivering something into production that much. So I was learning, I was loving it, but it took time. And then because this person was like had lots of responsibilities, I couldn't always take him and then, please sit with me, teach me how to do these things, that kind of stuff. But I loved it. I was doing the thing that I was taught to do. The maintenance was, and can still be, a nightmare, because actually test automation or automation in test is programming, guys. It has the same characteristics of a good production code. It has to have. If it doesn't, then you mean that you are opening yourself to so many maintenance problems, so many like refactoring problems. It can be a nightmare. Like I know some friends who have a job of like going in, and I think Richard Broadshaw talk about this in the previous talk as well. Like just going and try to fix the build. It's red, let's try to fix it. I mean, I have seen scenarios like which test automation code was never maintained for a year, 1 year, and then what they did was if the build failed, they had just commented out the failing part. And even that, if they were able to like if they could get themselves up to have a look, they had this psychometric complexity of 9. So when you went in a function, you went in, okay, what does this thing do? This go in, oh, it does that, go in, and you had to go 9 levels deep to actually see what the code was doing. So that is a maintenance hell. And I spent like weeks trying to convince them, just please, let's get rid of this old stuff, and let's leave it there because it's been there for 1 year. You didn't change it. It's a nightmare to maintain. Let's rewrite it. I mean, it's not that hard. So it consumes a lot of time, right? Now, I had attended like CraftConf 2016. It was in Budapest, and I was lucky enough to get a workshop with Dan North, the creator of BDD, also ex-salt worker. So he he was talking about these two things, right? When you are doing automation or even like full scale manual testing, you are missing two things. One, opportunity cost. What could I have been doing if I wasn't doing this, right? If I'm trying to automate everything, then that means that I'm spending lots of time on something that might not be uh, that useful, right? You can, for example, a good example I have is like visual regression testing. Do you know what visual regression testing is? Okay. Visual regression testing is this. For example, you have a website, right? You have some components on the website. What it does, it takes a screenshot of your website, and then when you deploy a new version, it takes another screenshot, and then it compares with the first version. If there are some like visual defects, it recognizes the pixels which are not in line, and then tells you these areas are faulty. So let's assume that you are doing that, right? What you have to do is you have to go in and have a screenshot of the system, and then the next version you have another screenshot of the system, and it fails. So for example, a web framework, when something fails, we know what's failing, right? It can say that, oh, I couldn't find this selector, I couldn't find this item on the page, I couldn't find that, whatever. I mean, it has a definition of the error. Now in visual regression testing, we don't know that. We just know that the page have, for example, failed 10%. It had a 10% difference of the first version, right? What you have to do, you have to go in and have a look at the second screenshot. You have to see with your eyes what's the difference. If you don't see that, you don't know. I mean, it can be a failure which is valid, but it might not. It can be just a banner that has changed while you are checking that. You can refine it, but still it will give you so little benefit on the thing that you have spent time on automating. You could have easily said that, okay, we have deployed it, functions are running functionally, it's good, let's have a look. 5 minutes, 10 minutes, okay, it looks fine, go ahead. That kind of stuff. I mean, there might be like there might be scenarios that you don't want to spend that much time on building a automation framework. You can just go in and have a look, or like you can, I don't know, like these companies in at our current times, like they sometimes they deploy things in production. We call it feature toggling. They toggle it for some people. If it fails, then they roll it back or just monitor it and then try to confine or divide the effect that it's going to have in a full scale production. So there are many ways around it. You'll have to assess what you are going to automate and what you are not going to automate. Flakiness. Flakiness is a term that I hate. I really do hate its guts. I mean, flakiness is a term when you use, for example, you have an automation script. Uh, it runs, for example, in a scenario that it passes, but in some scenario it fails, and you don't know why it fails. The reason I hate it is because if you don't know whether the system is failing or your tests are failing, then you have a problem. If you know that your tests are failing time and over again, like it passes sometime and it doesn't pass in the second time, you have to go fix your tests. If the scenario is the other was, if your system is flaky, for example, the system under test is passing for some runs and it doesn't pass for the others, then your system is a problem. You have to have a look at the system and try to fix that flakiness. So flakiness you have to get rid of. I mean, there can be many reasons of flakiness. It can be synchronization issues that, for example, a web page is not loading properly once you test it. I mean, you can have many other elements of flakiness. You have to just remove them. It's your arch enemy. You may have to play catch up with the team. Now, this is a tricky one. The main objective of Agile, to my understanding, is to put the team together and not leave things at the end, not do the testing at the end, right? So if you are doing your automation after the product is properly coded and you have a like runnable binary thing, then you have a problem there, right? Because you are not doing Agile, you are just doing mini waterfalls. What you have is like you have an analysis phase and the developers develop it, and then you take it over as testers, and then every sprint you have to test something. Now there should be better ways to do it, right? I mean, you should be able to go into the system and pair with developers to find some ways to automate it even before the code is executed. So in that scenario, if you are not doing that and you are playing catch up with the developers, then that's a huge problem. Because most of the time you will notice, like most of the time you don't have enough time to test things, right? The testing time is always cut off. So if you are playing this game, developers will have their time to code it up until the last day, and you won't have the time to test it properly at the end. So you don't want to play catch up with them. You have to be there from the start. You have to find ways of automating things before it comes into your hands as a runnable project. So the cool stuff, it was very satisfactory to create your own minions. I mean, I had so many times people coming behind my desk and checking, what are you doing here? I'm automating stuff. Oh, it's running by itself. Yeah, it does. And then they see these like websites opening up and then fields filling, buttons pressed, that kind of stuff. It's very cool. And actually, you feel like it. You feel like all those things that I had to do manually before now are being done automatically, which is cool, which is satisfactory. And in my case, it was satisfactory for me to have, at long last, my coding skills to mean something. So yeah, now these were the two extremes that I talked about. Now, first one was complete manual testing. The second one was complete automated testing. So what is it? What is a tester's job? We don't do manual testing. We don't do automated testing. What do we complain? Go there. Oh, I think there's something there. Yeah. So I think there is a balance. Now I have when I was thinking about what picture to put into the slide, this came into my mind. Like, I mean, I'm not putting this as a tester is the captain of a plane, or like the pilot of a plane. The message here is this: like, you still have the human element, right? Who here would like to go into a plane that didn't have a human pilot? And we are slowly getting there, but we are still not there. We're far away from it. And the pilot is controlling a lot of things and seeing a lot of things that's very technical to be exact, but he doesn't have control, or who he doesn't have the technical ability to know all about them, right? What he does is he uses the technologies that's served to him, and he has this manual control over the plane, which in many cases he will have to intervene with the machine and try to steer the plane in a direct course. But still, he has lots of monitors, lots of data that he has to look at and make some decisions about it. Now, this to me is a nice way of putting a tester's role in a project team. You still, as a tester, have a responsibility of quality, right? But you still, only you are not, you are not the only person who has to take care of quality. You are the person who is, I mean, the best thing a tester can do is make people aware of testing, right? So you have to go in, you have to talk to your team, you have to steer them in the right direction so that they do their testing. And you still have to test yourself as well. You can't leave everything to machines. You have to go exploratory test, do some exploratory test. You will have time to write your own automation code as well, but still, you are the guide. James Bach has this analogy of like being the headlights of a car, a tester. So you are the one who is shining light on the road and showing what is coming up to the car. So you have to help people care about quality. The In our world, there are people who are saying that, like even in among ThoughtWorks, we discuss this. Like, do we need a QA? Do we need somebody who is concerned about testing? I mean, the developers are doing their tests themselves. Why do we need a QA? What's the job of a QA? Now, the job of the QA is like making people sure, making sure people are testing properly. So I use this example like a mother child thing. When a developer is developing something, he has inertly this desire to see the happy paths, the good paths. He's building something, or they are building something, and uh, they tend to not see what can be going wrong, right? So a tester's job is to talk to them, pair with them, and see what's going on. Have you written this test case? Have you written this unit test here? What have you done? That kind of stuff. I mean, pairing is extremely important. Now, in all of our engagements we do, we always do pair programming. That's dev, but dev pair test, dev QA pairs are extremely important. We do so many desk checks together. Like, as I said, we are engaging this upfront, not at the end. So we go in and do desk checks to see if the direction is going right. And I'm talking about shifting left, of course. When we are pairing with a developer, we are making sure that they are developing software with their tests written. Uh, we make sure that they do test-driven design, for example. We make sure they have covered most of the functionality even before going into the test environment, like writing the tests. You all know about the test automation pyramid, right? So the bottom layer is very wide. That's the reason, because most of the functional tests are covered there. So you have to make sure that developers are testing this product. And then this the like the summary of what I'm talking about. You have to embed the quality in the product. So you can't say that again. There's a nice analogy. Um, what's the what's your favorite car brand? Somebody. Tesla. Great. So, can you imagine a scenario where Tesla is building a car and then sending it over? Okay, have a look at this. How is it? Is it going on? Are the tires good enough? Is the transmission good enough? I mean, is the electric engine good enough to work? And let's have a look after we built the car. I'm not sure. I mean, what they're doing is they are creating a good enough tire, and then they are creating this marvelous electrical engine, and they are putting all those hundreds of batteries into the car, and they are ensuring that every part is like qualified enough, every part has this quality in it. So if they did it in the first scenario and build something and let's test it afterwards, that would be a failure, and that would be a catastrophe. So what they are doing is they are basically building every single component according to the quality that they desire. So that's what embedding quality in the product is. So those components, those other transmissions engines are your product's modules and roles. Every other role and every other part that you have in your product has to be aware of this quality. I mean, I even had scenarios like this, like the deadline is approaching, right? Like tomorrow, I have to be. I was talking to a developer, and they said that I have to deploy this code to test tomorrow. They deploy it, and the first thing I do, the application fails. I send it back, and he says like, "Yeah, but I had to send it over, so it was seen in testing." So that's not a good approach, and that product didn't pass the test anyway. While you are spending all your time with pairing and trying to find new ways and new ways of making people aware of this quality, you will still have time to do exploratory testing yourself. I mean, you will have time to do exploratory testing while you are pairing with developers. You will have time once, for example, your automated checks have passed, you will have time to see them for yourself, and you will have time to write some automation yourself too. What we are trying to do is like, again, coming back to the pyramid, the GUI layer or end-to-end layer is not zero. It's very small, but it's not zero. You will have to write some scenarios that will make sense as a like a product journey maybe, and then you will have to see the results of them very quickly. But still, you will have these um, insurance in your mind that all other functionality, all other edge cases, all other different things that I didn't think in this happy path or journey is being covered in the lower levels of the pyramid. Like in the plane analogy, keep your eyes on the dials. You have to set up so much like information radars in your project. You will have to see, for example, let's talk non-functional or cross-functional. You may set up some radar saying that, okay, this service is failing our performance test. It was supposed to be responsive like under 1000 user load, and then it had to respond in 1 second at most, but it's failing that. Or like, for example, this type of error has been showing up very frequently. Why? Or this test has been failing, it has been flaky. Why? So you will have to have lots of radars around to see what's going on in the project. I mean, and you have to make this visible as well. Because you have to show the team that this some things are not going good, and there has to be some action to be taken. So you have to keep your eyes on the project. I mean, it doesn't have to be like automated radars. You have to have the ability to go in and check your product and check your um, code basically for possible scenarios that it shows some possible defects. Mentoring people. Now, I had a very nice colleague who was doing testing with me actually, and then he moved over to development. The best thing was once you make people aware of testing and how testers think, they tend to think those things beforehand, right? So after he moved to development, the codes that he sent me to test were becoming much cleaner. I mean, I was finding much less bugs, and he was aware that, okay, once I send this over, I think they will look into this, they will have a look into that. So it was getting better. I mean, once you make people aware of what the testers are basically thinking of, it will be much easier for you to test that product. And believe me when I say this, some people think that testers uh, become happy or feel confident when they find bugs. Myself, I feel happy when I fix bugs or when people fix bugs. I'm much happier when there are less bugs in the system. So I think this has to be the mentality over all the testing project. Like, you have to think that as a part of the team, you are not, we are against silos, so you are not a testing team anymore, you are a part of the project team. So you have to own the product and you have to be happy with the product, so it's doing something good in production. Okay, so that was my slide. Thank you. And questions, please. Sure, go ahead. Yeah, not that much. I mean, let me give you a person, like, I mean, because the quality is so high, it's very hard to say he was slower, because like if he was slower 20%, and then there are other developers who are giving me more buggy code, and then I have to return and fix those bugs and then see if the bugs are fixed. So the total amount of time I spent with him, or the one who passed from like QA to developer, was much less, because he was building this software like with quality. I had to rethink things very less. Go ahead. Definitely, definitely. Yeah, I mean, exactly. Some people say, for example, we are a big advocate of TDD, right? Some people come to us and say, but when I do TDD, it's much more harder and takes a lot of time. First, the time that it takes extra decreases over time, and second, as you have mentioned, like the total quality of the product is so much higher that you will, in total, you are spending less time in that product itself. Yes, yes. Yep. Definitely. It's all about the product and it's all about the client, right? So, yeah. I am very sorry that I'm very excited. I've been doing this for more than 2 years, but because it's a new country and new language, actually, I didn't give too much speeches in English, although I love to talk. So sorry for my excitement. So, thank you very much for attending. Let's huddle. Thank you very much.